Good morning, everyone. This is Architect Quinto from the United Architects of the Philippines and at the same time from the Philippine Institute of Architects. Now, as I know that this scientific forum is going to be attended by various professionals coming from the Philippine Institute of Chemical Engineers and the Philippine Institute of Civil Engineers, and of course the from the profession of architecture. So I guess m- each and every one of us belonging to these uh, kinds of organizations have something to learn from uh, this talk, from this presentation that I'm going to give you this morning. Um, but being in the architectural profession, my my presentation will be about buildings, and I am sure that the chemical engineers as well as the civil engineers will have some insights that belong to their profession, and hopefully those insights can coincide with the points that I'm going to share with you this morning. So this is about the carbon footprint of buildings. And later I will explain more in detail the direction that I will take, which is on building materials. So by the way, this presentation is also in line with Sustainable Development Goals number 11, which is about sustainable cities and communities. So first of all, why buildings? Okay, so this presentation is anchored on the premise that buildings account for about 30 to 40% of the carbon dioxide equivalent or emissions that go into our atmosphere. So this atmosphere is, of course, something that is able to protect us from the harmful radiation coming from the sun, which result uh, to what we call the greenhouse effect. Uh, and studies have showed the relationship between the the CO2 that is in our atmosphere with the global temperature. So as you see here on the screen, there is a graph that shows us the level of concentration of CO2 in the atmosphere and how it correlates with the rising global temperature, which most of us know as climate change. So this climate change is changing the means. It's changing the extremes, meaning that the averages that we have, in this case, the temperature is increasing. Okay, so the amount of rainfall that we have is increasing, and this also brings about the changes in extremes. So if we ever have a warm temperature, it becomes extremely warm, and if it is cold, then it goes to extremely cold. If it's drought, it's extremely drought. If it's rainfall, extremely increased rainfall. If it's about typhoons, and then this leads to extremely strong typhoons, strong winds. Now, it is good to note that there are still some people, scientists, who deny this climate change. However, uh, time and again, there are many papers, publications that say that there is a greater than 95% certainty that humans did it. No, you and I are contributing to this climate change. So there is a kind of a contention, uh, perhaps before, but rather less now, that there is really changes in the climate following cycles. However, with a greater certainty that it is not, it is more of human causes rather than natural causes. So again, why buildings? Because it is responsible for 40% of the energy consumption globally. And then it is also responsible to about one third or 33% of the greenhouse gas emissions. So therefore, if we in the building industry, in the built environment, is able to make some improvement, make some innovations, developments to lessen the way buildings are consuming energy, then we will be able to make a dent, make a significant effect overall on what happens or to the climate, or we are able to make some improvement in the way climate is changing. Therefore, hopefully, avoiding what we what we dread so far, about those changes in the means and changes in the extremes. So there is this article about this, why buildings are the foundation of energy efficient future. Um, okay, now there are approaches, okay, that we can consider on how to go about, the steps that we can make in improving the way we build. So the first question, the most fundamental question, is something that that goes like this, no? Is a new building really necessary? No? Is do we really have to build? And this is a very simplistic question as it seems, but our education, the way we are taught in school, and the practice that we make, that we do, is always bent on building. No? Is always bent on producing something, and this is what we are taught in school. No? Design an airport, design a hotel. Okay. Now, rarely do we consider uh, using what we already have. So this gives us, or this leads us to a basic a, a theory, that uh, the greenest building is the one that is already existing. So if you go around the cities, you have seen uh, buildings here in Davao that has been standing for several years and seem to be abandoned, okay? Or you have seen buildings that have been demolished. You have seen buildings that seem to have been neglected. So uh, instead of building something new, can we look at those buildings and find out, how they can be used rather than be demolished. So why? Because to build a new one, to build something new, can cost us a lot of environmental uh, environmental consequences, uh, rather than re refurbishing, for example, what has already been constructed. Many architects call it renovation. Some people call it reuse, or adapting a new use to an old building, or maybe repair in a very simple way, extending the use and functionality of a certain building. Okay, now if we ever make a decision to build a new building, to build a new one, then we have to consider certain theories, okay, or certain practices, good practices uh, on the design. Okay, so the first one is we make sure that the design is able to optimize, to make good use of the resources. For example, uh, we make use of strategies that prevent waste, something that uh, will make the use of space more efficient. Let's say a space can accommodate different kinds of activities. Can the space can become very flexible for small and large gatherings, for example. The space can be used in extended number of hours, not just a particular time of the week or a time of the day. So the design should be able to justify the price. Nowadays, my colleagues in the architectural profession is looking at the numbers like 40,000 pesos per square meter. So that's, I mean, that could be pricey. It could be lesser than that, or it could even be more than that. But we know that whatever investment is necessary, and that investment should be justifiable. And lastly, no, to we make sure that the design that we make creates value in terms of how it improves the lives of the people. I found this information from dqi.org, mentioning or insisting that buildings should be designed for quality. So research can be made to validate, or that designs can truly become something that makes, for example, the recovery of patients in the hospital, uh, the recovery will be much shorter. No? Um, Improvement of how the students learn in schools, better grades, for example, better understanding, comprehension, or more productivity in the workplace. So we can look at this, no, and make sure that whatever we do in our building designs is something that will improve productivity in a way. So in that situation, we are able to make sure that whatever cost, environmental cost altogether, economic cost, environmental cost, the investment that we make in those buildings uh, can uh, can be related to certain improvement in the way we we perform our work. Now, these are the various aspects that we can look into regarding the design. So, so the design impinges on construction as well. So we make sure that our construction has low impact on the environment. They are thermally comfortable. We make sure that our buildings respond to the tropical climate that we have, which is um, hot and humid. Uh, it is uh, it is unthinkable nowadays not to use air conditioning systems. But if we ever have to use it, then it should be used efficiently, making sure that the amount of energy that we use is just enough, and and then we avoid overcooling the buildings, or we provide certain amount of insulations to make our cooling systems, cooling equipment much more efficient. So we can also look at the efficient utilization of lighting, no? Combining or taking advantage of natural light, or making or taking advantage of high lumen output of the of our lighting system. This also includes other utilities such as water, um, employing or using faucets that do, that use less water without compromising the efficiency in washing, in flushing the toilet. And lastly, we can talk about the use of sustainable materials. By the way, so this number five uh, uh, element is something that I will be expounding on this presentation about the materials. Okay, so first is we look at materials in terms of their embodied energy. So the embodied energy is the total amount, no, accumulated amount of energy that is used in producing the material. Okay, so including transportation, packaging, so on and so forth. So we make sure that the materials that we use are fit for the purpose. So uh, we try to find materials that do not require a tremendous amount of transportation, and and materials that have um, low or minimum chemical or mechanical transformation. So materials like those that we find in nature and can be used almost directly from nature are the materials that have very low embodied energy, and the opposite is something are materials that needs a lot of uh, of heating, grinding, mixing, so on and so forth, uh, to assemble, and materials that needs a lot of ingredients from faraway places, and putting them together, and then after putting them together, manufacturing it uses a lot of transportation or packaging, so that it arrives at the end user. So here are some of the materials that where the embodied energy is presented. So uh, concrete with 25 megapascals would be rated at 1.1. So you notice that the ones that I have highlighted are the ones that are commonly used in buildings. Of course, the paint, plywood there. And then we shall also look at materials that are so-called risk-free. Okay, so these risk-free materials uh, are materials that do not exploit human population through perhaps unfair or unjust labor practices. No? It doesn't, and it should not undermine biodiversity like mining or destroying certain uh, places that are that in the end compromise or destroys biodiversity, killing or endangering species. And this material should not pose any harm to human health, including other species. I remember a passage that we often hear, no, save planet Earth, but in reality, it's not save planet Earth. It is rather save us, no, who are living on planet Earth. Uh, so it is us that we are trying to save. It's not planet Earth per se. Now, in buildings, it is also good to understand that there are what we call layers of change in buildings. Like there are this is not literally layers, no, but rather there are components. Maybe that's a more understandable word. There are components in buildings that that have kind of like different lifespan, no. So this is something that that is uh, presented in this way. Let me explain this. For example, staff, no, staff. The first one on the left, 0 to 5 years. What are these? These are the various pieces of furniture that we put in our buildings. Uh, the supplies that we put, uh, the the storage places in building. Uh, so these things kind of like last for about 5 years until we change them. No? So a piece of chair, a table that we wanted to change because it's out of style. Okay, a bed, furniture, or pieces of furniture. Most likely, it will last for 5 years. Okay, or but I would not be surprised if some of us have retained no pieces of furniture for a longer period of time. Okay, these supplies, for example, the light bulbs, no, the things that we replace very often. Sometimes in a year, we have to change some of them, like a gasket in a faucet, or a heater or whatever. No, it has something to do with the years of warranty. No? Most of the pieces of equipment that we buy for our houses, okay, like washing machine, it comes in with a 1 year warranty. So maybe it will only last a few more years. You have to change them. So these are the stuff. Okay, um, these are really meant to be replaced. Okay. So okay, now the next one would be the space plan. So these are the interior space alterations that we do. Now, for example, what we have on the walls. For example, usually in the context of the Philippines, this would be the painting, painting. Okay, so mm, perhaps in some areas the finishing, maybe a wallpaper or nowadays you see a lot of fluted panels. It's like it has grown very viral. No, you see fluted panels everywhere. Okay, then we have the services. Okay, services. So 15 to 25 years. So these are the mechanical systems, no, the electrical, the cables, the circuit breakers, the pipes, the the plumbing system that we have. This can last for a very long time, no. Um, these materials can for example, polyethylene pipes, they last for a very long time. Okay, so and then here comes a more something that will really outlive us. This will be the structure. 50 years, 100 years. Okay, so primary structural systems in buildings. So 50 to 100 years. No, what am I saying? What am I saying here? So uh, for structure, for example, which is made of concrete or steel or yeah, very durable materials, then it makes sense to invest on something that will last for a very long time, even if they cost us certain disadvantage in terms of being a green material. Why? Because the use is so prolonged, no? So prolonged. We it's like a pair of shoes, very expensive shoes or expensive pair of shoes, very expensive, very durable, but it can be used. You can pass it from one generation to a generation. So it's something like that. Okay, then we go to the skin. Okay, so 25, rather a shorter time. So these are the materials that encloses us, the buildings. For example, the roof, the roofing. Uh, the roofing is a part of our building that is exposed to many uh, elements, no? The sun and rain. Okay, so our roofing material should be something that can last for a very long time. Sana, no? Sana, hopefully up to 50 years. Like you don't need to repaint it or it doesn't corrode easily. So that if you properly maintain it, then you can minimize repairs or even minimize replacement. Then the last element here is the site, no, where the building is located. So this is something that is they call it like infinite, like forever. We cannot do much about it. It's on the land. Okay, so we are looking when we are looking at buildings and the materials that are considered, it would be on the space plan, services, structure, and skin. Sorry. Now another way of looking at materials in buildings would be what we call life cycle assessment. So by definition, it's the analysis of environmental impact associated with the material. So the one at the bottom is circular. Okay, so we starting with our resource recovery on the left side, no, we manufacture it, we package, and then we use it. Okay, we install in our houses, and when their useful life ends, we remove them or we replace it. So uh, then then hopefully, no, these things that we remove will become again the resource for making something new. Okay, so something that we can use again, and then something that we can manufacture again, so that it can become another or a material that is supposed to be used again in the building. So the one on the left is the more sustainable practice, where the resource uh, is the waste, no, supposedly that we have generated after using such material. So the one on the left is more sustainable, but the one on the right that is linear is actually the same, but uh, but something that lacks circularity. Okay, so extraction of material, production of the material, packaging and distribution, use, and then it ends in a landfill or a waste. Okay, so uh, it ends there. So that's why if it is a circular, then then the material is the wasted material becomes the the raw material, no, for producing something. So we can imagine life without wi- sanitary waste facilities. So we can look at materials, whether they can be, no, where they can be, uh, which favors this kind of a circular pattern rather than something that will just be thrown off afterwards. Now, let us look on another aspect of the material, which is what we call embodied carbon. Okay, so just for illustration here, uh, 1 ton of CO2 equivalent, no, CO2e, 1 ton, okay, of that carbon dioxide equivalent. So we need, if you want to produce 1 ton of CO2 E equivalent, is we need to burn 225 liters of gasoline. Okay, so uh, yeah, what? So if you can imagine, no, if you have a car or a vehicle that has let's say what 50 liters of gasoline per tank, and so you kind of like imagine filling it up, no, for 5 times. Okay, and then that one, that burning of 250 liters of gasoline, more or less, no, what it says here in the literature that I got, 225 of liters of gasoline will produce 1 ton of CO2 equivalent. So this is just for illustration, so that we can understand the different embodied carbon of building materials. So you see here, per kilogram of timber, uh, using uh, 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 1 kilogram of timber, you will be uh, having zero point 0.3 kilograms of CO2 equivalent. Okay, so uh, timber is highly sustainable material. No? There are literature that tells us that timber has a negative embodied carbon. Why? Because it used to, okay, and when it's still a tree, it used to capture, okay, carbon. So therefore, it 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 actually is is has a lesser embodied carbon. But timber, as we know, needs to be sorry, the wood, no, the wood that we are able to harvest in the forest, no, we need to process it, no, and then we need to cut it to dry it, no, to reduce its moisture content. All those will require energy. So therefore, that's why the timber has some 0.3 kilogram. However, no, cement has a higher embodied carbon, steel, plastic, 3.5 kg. Okay. House, for example, the house to build about a 100 square meter house, you would have used, sorry, produced. You would have produced 80,000 80,000 kilograms uh, of carbon dioxide equivalent, like 8 tons. Sorry. Now, what are the 10 highest um, building materials in terms of carbon dioxide equivalent? Uh, so I have here a range, no, from the lowest to highest. Gypsum, okay, gypsum, zero point 0.3 kilograms. Okay, concrete, half a kilo, and then cement, no, which is a composition of, sorry, concrete. Concrete is a combination of cement, sand, gravel. Okay, so but cement itself has a higher carbon, embodied carbon. Okay. Uh, then the bricks, glass, ceramic tiles, which we use a lot, we import a lot, no, from other countries. Plastics, laminates, they come in laminates. Steel that we use for reinforcement, copper for for uh, for our electricity, and aluminum. Most of the time we use aluminum for window framing. So, but let us be careful in looking at this embodied carbon. No, for example, concrete only half a kilo, but we use a lot of it. No, we use a lot of concrete. So therefore, uh, concrete foundation, concrete columns, so on and so forth. No, so even if we use a lot of it, if it's used again, no, for structural purposes, if you remember a while ago, no, structural up to 100 years. Okay, so we can use these materials, and their use is justified. No, here in the Philippines, it would be nice if you can use timber. No, but it has to be processed. Uh, it has to undergo a lot of processing, so that it it is it is able to resist infestation, uh, so that you can preserve it, so that it doesn't deteriorate, both structurally and materially. Okay, uh, timber is a very sustainable material, but then again, durability here in the Philippines is very much an issue. Okay. Okay. So aluminum, for example, has a very high embodied carbon, but it's used uh, quite sparingly. No, and by the way, there are alternatives to aluminum frames, okay, which is plastic frames. Okay. So, in conclusion, what can we make? So, now first, the first question. Let us explore renovation and refurbishment, improvement, reuse of existing buildings that we have. No, so for example, you have a big house. Okay, rather than demolishing the big house, is it possible that the big house become two, split into two or three, and several families can use those uh, divided parts, uh, and then the family size has been becoming smaller and smaller anyway. So look at those things. If if you have a building that you seldom use, or a building that is not used all the time, then maybe we can check whether you can make it available, no, for the others to use. Make it rentable, for example, things like that. So these are the things that we should consider, rather than concluding that we need, no, we don't have a building, therefore we need it. No, sometimes uh, renting, no, renting something that you will need is could be a better option. Okay. Now, second is we seek quality and value in the design. Okay. Uh, we try to make it uh, efficient. Efficient. We try to make it uh, uh, nice to use, something that is functionally supportive of whatever uh, we do, whatever activity that we do in those places. Bedrooms doesn't have to be big, okay? Uh, uh, Hotel rooms doesn't really have to be that big. You have seen this. Condo units are becoming squeezingly small, but what is important is that we are able to use it. So then, uh, going sustainable would be not just focus on one thing, but a combination of various methodologies. No, but the overall goal is to lessen the embodied carbon. Material is not is one thing, but it's not everything. Okay, so and and then we should favor the use of low embodied energy materials. No, if something that we can source here locally, uh, that would be something that is worthy of being explored. And lastly, favor low income embodied carbon materials. And that's it. I hope you have learned something.